Cathode ray oscilloscope CRO is a measuring instrument. By using this, we can measure the amplitude. Now, from this point to this point, how much the amplitude is there, amplitude peak to peak, peak value, and time period. Uh, by uh, by taking the reciprocal of time period, we can measure the frequency. And if two waveforms we are measuring at the same time, that time how much delay is there, that also we can measure. So phase delay. So these are the parameters we can measure by using the CRO. And this is the block diagram. Uh, Here we apply the measuring signal, and that will be displayed on this screen, and we can measure the voltage or time period. So for that, now this signal is should pass through the horizontal section, and here, sorry, vertical section, and again it should synchronize with the horizontal section, and that should be displayed on the CRT tube. So now one more section is there, power supply. These powers, different types of power supplies we are using to apply for all these blocks. So this is the block diagram. Now we will see the in detail. If we are applying the signal to measure the waveform, and this is applied to the vertical amplifier, and the signal is measured on the CRT screen, and it will look like this. And this beam is moving from starting point to the and deflecting in the vertical direction and also deflecting in the horizontal direction. So this is done by these vertical deflection plates and horizontal deflection plates. Because of these plates, beam is moving in the vertical and horizontal directions. Now for this, to get that beam, so for this vertical and horizontal deflection plates, the signal should be applied at the same time. For that, so now the input signal, whatever the signal is given to the amplifier section, that is not directly given to the vertical deflecting plates. That is applied to the vertical amplifier. So because this signal is a weak signal that can't deflect the deflecting plates, that's why that signal strength is increased or signal is amplified in the vertical amplifier. And after that, that signal is applied to the delay line. Why to give it to the delay line? Why? Because whatever the signal is there, now to the horizontal section and for horizontal deflecting plates and vertical deflecting plate need to apply the signal at the same time. So if you see, after the amplification, the signal is applied to the horizontal section. Now here three circuits are there, and the signal is passing to these three circuits and are finally applied to the horizontal deflecting plates. So how much time it required to reach the horizontal deflection plate, that time is needed to be calculated, and that is provided in the vertical section to apply the signal to the vertical and horizontal deflection plates at the same time. So for that, this delay line is needed. So after the amplification, signal is applied to the delay line, and with the after this delay, it will keep the signal for some time, and after the delay, it is applied to the vertical deflecting plates. So the amplified signal again is applied to the trigger circuit, and this trigger circuit is synchronizing the input signal with the horizontal section. So this is generating, the trigger circuit generate the trigger pulses which are applied to the time-based generator to generate the sawtooth waveform. This time-based generator is generating what? Sawtooth waveform. And this waveform is used to deflect the beam in the horizontal direction. Now from this position to this position, so beam should move. For that, this sawtooth waveform is applied. Now if you see here, rising slope is there. So rising slope means what? Beam is moving in the forward direction. So beam is moving in the forward direction, and it is going up and down means because of the amplitude, vertical deflection plate. And here if you see sudden fall. So sawtooth means what? It is rising and sudden fall. So this fall means what? After reaching the end point, again it's supposed to come to the starting point, and this waveform should, this beam should move in this direction. So for that, to reach this starting point to ending point to starting point, so this is needed. So because of this sawtooth waveform, beam is deflecting in the horizontal direction. So this again, this sawtooth waveform is not applied directly to the horizontal deflecting plates. So this is signal strength is not sufficient to deflect the plates. So that's why this is applied to the horizontal amplifier to amplify the signal or to increase the signal strength. And after that, the signal is applied to the horizontal deflecting plates. Now, this is the CRT. In the CRT, electron gun is there, which will generate the electron beam, and it is passing through the deflecting plates, horizontal and vertical deflecting plates, and it is touching the phosphorus screen. And when beam is touching the phosphorus screen, light will illuminate on the screen. We can see the waveform like this. Now here one more power supply generates a low voltage and high voltage power supply. Low voltages are given to the circuits, all the circuits. Now high voltage is given to the CRT. Now we study the CRT construction. Now this is the CRT. The complete CRT is assembled in the vacuum glass. Now this is the vacuum glass. And here for this pins, voltage is applied. With that voltage, heater will get heat, and thereby cathode will generate the electrons. Now here you can see the cathode will generate the electrons. Cathode will generate the electrons. And these electrons are passing through the control grid. We can also call it as a grid or control grid. And this control grid, for this control grid, negative voltage is applied, very high negative voltage is applied. So that will repel the electrons, thereby. So this control grid is generating the electron beam. That beam is again passed through the anodes. Now here we have three anodes: free accelerating anode, focusing anode, and accelerating anode. So by applying the very high positive voltage to these accelerating anodes, so the beam velocity can be increased, and it will move towards to the screen through the vertical deflecting plates and the horizontal deflecting plates, and it will touch the screen. And screen is coated with the phosphorus. This screen is a phosphorus screen. So when the electron beam hits the screen, then the light will illuminate on the screen and the beam will be displayed. Now, by controlling the negative voltage on the control grid, we can control the intensity of the beam, and by controlling the voltage on the focusing anode, we can control the focus of the electron beam. Now this is about the CRT, cathode ray tube.